The most distant human-made object is NASA's Voyager 1 spacecraft, which has managed to venture into interstellar space. Imagine launching a spacecraft 45 years ago and still exploring regions it was never expected to reach, while past its intended lifespan. This is the extraordinary reality of NASA's mission, which is reshaping the way we view space exploration. However, there's an even more astonishing aspect. This daring spacecraft is not only millions of miles away from its origin, but it also continues to transmit data back to Earth using technology older than a cassette player. That's not all. The spacecraft, launched in 1977, made a groundbreaking discovery that has stunned the scientific community and captured global attention. What exactly is this remarkable find in the farthest corners of space, and what implications does it hold for us on Earth? There was a pivotal moment in history when two of the most incredible space missions were launched, marking the beginning of the space exploration era. Thanks to the brilliant mind of Gary Flandreau from NASA's Jet Propulsion Laboratory, a perfect trajectory was mapped for the probe to reach distant planets such as Jupiter, Saturn, Uranus, and Neptune, using only a pencil and 21st-century engineering tools. In the late 1970s and early 1980s, Flandreau made a stunning revelation. The four gas giants would align in an exceptional cosmic pattern, forming a celestial necklace along with Earth. This alignment allowed spacecraft passing near each planet to gain speed, as if being pulled by an invisible rope. Due to this gravitational boost, a journey that would have normally taken 30 years from Earth to Neptune could be completed in just 12 years. However, there was a catch. This alignment occurred only once every 176 years. Seizing this rare opportunity, NASA acted swiftly. Within just 15 days, they launched two identical spacecraft, Voyager 1 and Voyager 2, in the summer of 1977, aiming to capitalize on the cosmic alignment. Little did they know that these twin spacecraft would go on to break all space mission records. More than 45 years after their launch, Voyager 1 and Voyager 2 are still operational, sending valuable data daily from the outer reaches of our solar system. These remarkable spacecraft have become the farthest objects ever sent from Earth, having journeyed far beyond what was initially imagined. This is especially impressive considering their original mission was expected to last just 4 years. However, these interstellar pioneers have kept surprising us. At the start of their journeys, they provided extraordinary close-up images of Jupiter and Saturn's moons, revealing worlds far more active and dynamic than scientists had predicted. Discoveries like active volcanoes and icy landscapes forever changed our understanding of these distant corners of the solar system. Voyager 2, in particular, was the first spacecraft to visit Uranus in 1986 and Neptune in 1989, becoming the only probe to ever travel between these two planets. It surprised scientists with astonishing revelations in previously uncharted territories. Located over 14 billion kilometers from Earth, these compact probes continue to defy all expectations and expand the boundaries of human knowledge. The Voyager journey began with a gravity assist maneuver around Venus, a technique never before attempted by any spacecraft on its way to Mercury. This made the Voyagers true pioneers. The journey to Jupiter took them 10 times the distance between Mercury and Earth, requiring them to pass through the dangerous asteroid belt, a feat previously achieved by the Pioneer 10 and 11 probes. But the challenges didn't end there. With just 69 kilobytes of memory, far less than that of a modern smartphone, the onboard computers had to use their own intelligence to manage the complexities of the mission. Data collected by the spacecraft's instruments was stored on magnetic tape recorders before being transmitted back to Earth through a transmitter that used only 23 watts of power, about the same as a light bulb. These probes were equipped with 12-meter diameter satellite dishes to maintain communication, using light-speed radio waves to send and receive messages. However, the increasing distance from Earth, advancing by 3 to 4 light seconds each day, created significant challenges. For instance, it took more than 18 hours for signals from Voyager 2 to reach Earth. Growing background noise from radios, televisions, and cell phones made it more difficult to detect the spacecraft's faint signals. Despite these hurdles, the Voyager probes continue to defy expectations, surprising astronomers with unexpected discoveries in the vast interstellar void. Their mission has redefined our understanding of the cosmos, reshaping our perception of the unknown. Beyond our solar system lies the mysterious Oort cloud, a vast region containing comet-like objects bound together by the sun's gravity, extending to the nearest star. Although the Voyagers continue their slow movement toward this distant realm, their entry into interstellar space began when they crossed the heliopause, the boundary between our solar system and interstellar space. Initially estimated to be about 50 astronomical units from Earth, the mission continued to receive funding as the spacecraft approached this milestone. However, crossing this boundary didn't immediately reveal the expected changes in the environment, leaving scientists puzzled. The entry into interstellar space was anticipated to trigger an abrupt increase in cosmic rays, high-energy particles traveling at nearly the speed of light, ejected by supernovae and other cosmic phenomena. Most high-energy particles are deflected by the magnetic shield of the heliosphere, which protects our solar system from external threats. The Voyager mission team closely monitored any shift in the magnetic field as the spacecraft entered the interstellar medium, a region composed of ionized gases influenced by nearby stars. The interstellar magnetic field was expected to differ from the heliospheric changes. On August 25, 2012, Voyager 1 finally crossed the heliopause and transmitted fascinating data confirming an increase in plasma density. However, there was no change in the magnetic field. This was unexpected, as scientists had predicted that moving from a region dominated by solar magnetic fields to one influenced by other stars would result in noticeable changes in the magnetic field's direction. If you have thoughts, let me know in the comments. And if you like the video, don't forget to hit the like button and subscribe to the channel. Voyager 1's journey into the great unknown has significantly altered our understanding of space. Its data continues to provide insight into regions previously thought to be unreachable. Even as these spacecraft venture further into interstellar space, each new discovery adds to the growing picture of a universe that is far more complex and fascinating than we ever imagined. One of the most notable aspects of the Voyager missions is how they have been able to send back data despite the extreme distances. The spacecraft are now so far from Earth that the time it takes for their signals to travel back has increased dramatically. This means that the teams monitoring them on Earth are dealing with significant delays in communication, which only adds to the challenge of operating these probes. Yet, despite these obstacles, the Voyagers have proven remarkably resilient and continue to exceed expectations.